Hello everyone and welcome to IT-KnowledgeBase. In this video, I am going to demonstrate to you how to configure site-to-site VPN between two sites or interconnection between your head office and branch offices. These are three parts of mastering video series: peer-to-peer shared key, SSL TLS, and IPsec VPN Tunnel. We are using the latest pfSense 2.7.0 Community Edition, and also the same applies to pfSense Plus software. In part 1, we will configure site-to-site VPN with a peer-to-peer shared key VPN tunnel, as this is deprecated due to refusal with today's security standard, but you can still configure it with some technical congestions. However, in the future release of pfSense CE or Community Edition, peer-to-peer shared key option will be removed finally. In part 2, we will convert this non-security standard VPN tunnel to a peer-to-peer SSL TLS VPN tunnel, which is recommended in all situations. And this is the most secure and meet today's security standard. And then in the final part 3, we will also see how to configure an IPsec VPN tunnel and interconnect your offices. Since you cannot convert your existing peer-to-peer shared key and peer-to-peer SSL TLS VPN tunnel to a new IPsec VPN tunnel, this is a completely different configuration, so we will see in action and configure it from the scratch. Many of you asked me to create an easy-to-understand step-by-step tutorial on how to create a pfSense site-to-site VPN tunnel between two pfSense firewalls. I tried to make it as simple as possible. Consider setting up pfSense first. I think it's worth explaining what pfSense and site-to-site VPN are and what their advantages are. Then move on to implementation first if you are not already. Then watch my earlier video installing pfSense, LAN, WAN and DMZ to set up your environment first, or if you have already, then move to continue watching this video. pfSense is a firewall distribution based on the FreeBSD operating system. The distribution allows implementing mechanisms such as NAT, CARP, VPN, including PPTP, IPsec and OpenVPN, and the captive portal. In addition, it performs the functionality of a classic firewall, dynamic DNS, DHCP, and proxy server, which is so much easy to deploy. Why site-to-site VPN? Site-to-site allow you to configure only gateways in remote subnets, and you do not need to configure the network nodes themselves. In simple terms, the site-to-site method connects two offices to a single network, and the point-to-site method connects remote employees to the office. In this video lecture, we will consider an example of connecting two existing networks, physical and virtual. You can configure your site-to-site VPN over the peer-to-peer shared key, peer-to-peer SSL TLS, and IPsec VPN tunnel. Please note, OpenVPN has deprecated the peer-to-peer shared key mode as it does not meet recent security standards. The shared key mode will be removed from future versions, so you should convert any existing peer-to-peer shared key VPNs to SSL TLS and avoid configuring any new shared key OpenVPN instances. But in our later videos, we will see in action how to convert existing peer-to-peer shared key into SSL TLS and configure IPsec VPN tunnel from the scratch. Setting up your pfSense network and satisfying all the prerequisites are fairly very straight. If you really wanted to know how to install and configure the pfSense firewall in your network, then watch my related video created earlier. Please note, all the traffic should forward through the pfSense firewall in order to establish a successful routing. In the local area network, all the servers and desktops should set the IP address of your pfSense firewall in their individual LAN gateway. And let's discuss our network scenario first. We have identically installed and run pfSense Firewall 2.7.0, the latest version at all of our branches. We also have two sites, head office and branch office, or could have more sites, and they might be located in the same city, out of the region, maybe countrywide, or in the different continentals, but out of your LAN premises. So how could you be connected to each remote sites and access the resources equally the same as you are working in your internal LAN to deliver timely and effectively remote support and share IT resources between the servers, desktops, and printers across the network? Today, we are excessively relying on using TeamViewer and AnyDesk for instant remote support and connectivity, configuring the NAT, network address translation, for opening the RDP, remote desktop protocol, secure shell, SSH, and FTP port through the port forwarding rule. But mark my words, creating a site-to-site VPN is more secure than using any third-party remote support applications. Nonetheless, if you connect your sites or branches to each other over the site-to-site VPN, then your network will be in your complete control. You could also enforce the centralized corporate policy to control internet activities, implementing Active Directory group policies to all over your interconnected branches, and so much indefinite viable controls. In this example, both sites pfSense firewall have a static WAN or Internet IP address assigned to their dedicated interface. On the second LAN interface also have assigned static LAN IP address, and both have a different IP version for 24-bit typical LAN network. We are also using server mode peer-to-peer shared key VPN tunnel with the IP address of 10.1.10.0/30 subnet because we only need two IP addresses to establish the tunnel between the head office and the branch office. Please note, in the latest version of pfSense 2.7.0, and similarly in the OpenVPN has deprecated the shared key mode because it does not meet current security standard. This shared key mode will be removed from future versions. But until now, we can use the peer-to-peer shared key for a successful demonstration. In our upcoming videos, we will see in action how to convert existing peer-to-peer shared key VPN to SSL-TLS VPN tunnel, which is more secure and meet today's security standard. The objective is to share IT resources between the servers, desktops, and printers across the networks. Now head to our primary head office pfSense firewall, and from there we will create our first site-to-site VPN server. For creating a site-to-site VPN server comprises the three steps of processes. Number 1, create a site-to-site VPN server. Number 2, configure a firewall rule for OpenVPN's new interface to flow in and out the traffic. Number 3, configure a firewall rule to open an OpenVPN port in your WAN interface to access the site-to-site VPN client connection. Now start configuring the site-to-site VPN tunnel on the primary pfSense at head office first. Open up your web browser to log into your pfSense firewall. First thing first, this is not very essential, but I would always prefer to add an image widget just to recognize the pfSense site at you are working now, and this is just for our ease only. Click on this plus sign and click on the picture. Add the widget title to the company name and click browse to add a picture. I have already added mine, so click on save. When configuring a site-to-site OpenVPN connection using a peer-to-peer shared key, SSL-TLS or IPsec VPN, one firewall will be the server and the other one will be the client. To configure OpenVPN, in the main menu, select VPN, click on OpenVPN, and in the server tab, click on the Add button. In the general information, type the description which should be relevant, and I would prefer to write S2S-BO, which pronounces site-to-site branch office. Disable this VPN server service for maintenance or any defensible reason. Server mode should be set to peer-to-peer shared key. Please note the warning here, OpenVPN has deprecated shared key mode as it does not meet current security standards. The shared key mode will be removed from the future version. Convert any existing shared key VPNs to TLS and do not configure any new shared key OpenVPN instances. This we have to take care of in the future. Set the device mode. Layer 3 tunnel mode is fine. Protocol UDP on IP version 4 only is fine here, but you could change it to TCP if you like. Interface should be your WAN interface. Receive the VPN connection. Local port 1194 is the default OpenVPN port, but you could change it if your ISP blocks this port. Shared key, leave this checkbox checked to automatically generate a shared key. We will use this auto-generated key for our branch pfSense client side. Data encryption algorithm, leave the default as it is the best. Fallback data encryption algorithm, leave the default. Auth digest algorithm and leave it by default too. Hardware crypto, no hardware crypto acceleration is fine. IP version 4 tunnel network. Specify the addresses used in the tunnel. This is just to establish a tunnel between the pfSense site-to-site VPNs. This must be a unique address and should not match with any of your head office and branch office's LAN network. I will specify my own separate private tunnel network 10.1.10.0/30. IP version 4 remote network. Specify the branch office network address in the CIDR format. which is located behind the branch office remote pfSense gateway. 10.0.30.0/24. Allow compression. Select the decompress incoming, do not compress outgoing. In the compression, select adaptive LZO compression. Compression enhances the traffic and I recommend to enable this. Now scroll all the way down until you see the gateway creation. Select the both or just select the IP version 4 or the IP version 6 traffic. I will go with the IP version 4 explicitly. Save the settings. Now configure the OpenVPN rule in the firewall for the new interface. Without this rule, your network could not flow in and out. In the main menu, click on Firewall. Now click on Rules. Select the OpenVPN and click on the Add button. Select the action and it should select to pass. Disable this rule if you want to for maintenance or any defensible reason. Interface should be your OpenVPN and it is fine. Address family, IP version 4. You could select IP version 6 either or both. The protocol is TCP, but would prefer to set it to any. It's better. Later on, you can restrict as much as you want. Source and the destination should be set to any. Provide the relevant description. I would specify OpenVPN traffic. When finished, click on Save button. And do not forget to click on the green button, Apply Changes. Now configure the firewall rule to open an OpenVPN port on your WAN interface. In the firewall, click on Rules, select the WAN item and click on the Add button. Set the action and it should select to pass. Disable this rule if you want to for maintenance or any defensible reason. Interface should be select to WAN. Address family, IP version 4 is fine, or you could select IP version 6 or both. The protocol is TCP, but we have to specify here an OpenVPN port which is using the UDP protocol. Select the UDP. Source is set to any and the destination should be set to any. Destination port range, drop down a list from and to and select OpenVPN. Provide the relevant description here. When finished, click on the Save button. And do not forget to click on the green button, Apply Changes. Now copy the generated key to transfer it to the remote computer. In the main menu, select VPN, click on OpenVPN. Select the Servers tab, click on the pencil icon or edit the rule. On the updated page, in the cryptographic settings section, shared key item, copy the entire contents of the field into a text editor, for example, in the notepad. We will paste this shared key in our remote pfSense gateway. Now move on to our branch office pfSense firewall. It remains to configure the remote pfSense gateway as a client. Open up your browser and log into your pfSense. Now in the main menu, select VPN. Click on the OpenVPN. Now click on the client item. Then on the Add button. On the page that opens, check the parameters. In the general information, type the description. Should be relevant. I would prefer to write S2S-HO because we are connecting to head office, which pronounces site-to-site head office. Disable this server if you want to disable this for the maintenance purpose or could be any reason. Server mode should be set to peer-to-peer shared key. Please note the warning again. OpenVPN has deprecated shared key mode as it does not meet current security standard. The shared key mode will be removed from the future version. Convert any existing shared key VPNs to TLS and do not configure any new shared key OpenVPN instances. Device mode, layer 3 tunnel mode is fine. Protocol, UDP on IP version 4 only. Always check with your VPN server, either configure to receive connection request on TCP or UDP. But in this example, we are using UDP on IP version 4, which is fine. Interface should be your WAN interface to dial out. Local port, leave this default or empty, not required here. Server host or address, specify the head office pfSense WAN IP address. In our case, it is 192.168.11.80 and the server port 1194. This should be your head office pfSense OpenVPN port. We are using the default port, so we will leave it default or change it if this is something else. Leave everything as it is. Take off the tick in front of automatically generate a shared key. In the shared key, paste the head office pfSense firewall shared key here, and we have copied earlier in the notepad. Data encryption algorithm, leave by default. Fallback data encryption algorithm, leave by default. Auth digest algorithm, leave by default. As default, it looks pretty strict and optimum. Crypto hardware, no hardware crypto acceleration is required and the default is fine. IP version 4 tunnel network, specify the addresses used in the tunnel. We were previously used in our pfSense server 10.1.10.0/RD. This tunnel network IP address or CIDR should be unique. Now specify the IP version 4 remote networks. Specify the head office network address here in the CIDR format, which is located behind the head office pfSense gate. And this is 10.0.20.0/24. In the allow compression, select the decompress incoming, do not compress outgoing. In the compression, select the adaptive LZO compression. Scroll all the way down until you see the gateway creation. By default, it's selected to both, but you could specify your specific network traffic. I will go with the IP version 4 explicitly. Now click on the Save button. This completes the setup. Now configure the OpenVPN rule in the firewall for the new interface. Without this rule, your network could not flow in and out. In the main menu, select Firewall, click on Rules, select the OpenVPN, and click on the Add button. Set the action and it should select to pass. Disable this rule if you want to, for maintenance or for any defensible reason. Interface should be selected to OpenVPN and it is fine. Address family should be your IP version 4. You could select this IP version 6 though, or both. The protocol is TCP, but I would prefer to set it to any is better. Later on, you can restrict as much as you want. Source and the destination should be set to any. Provide the relevant description. When finished, click on the Save button and do not forget to click on the green button Apply Changes. Now monitor or test the OpenVPN Site-to-Site VPN Tunnel's status. Remain in the pfSense branch office and head to Status and click on the OpenVPN. You should see if everything went well. If I did not commit a mistake, then a connection should be established. You will see a similar picture on the head office pfSense firewall. Back on the head office pfSense firewall, head to Status and click on the OpenVPN. You should see if everything went well, and if you did not commit a mistake, then a connection should be established. We can do two more things to also validate if the firewall rules are correct. Running a ping from a client on each firewall subnet. We are in our head office and initiate a ping from our client terminal. Open up a terminal and initiate a ping to the remote client IP which resides in the branch office. And yes, it's working. Now initiate a tracer or trace path in most of the Linux terminals. And the affirmative. Our site-to-site VPN is established between the head office and the branch office. Now both offices share and access each other's information. Both can access their network resources and contrarily. And it shows our terminal gateway here, which means our site-to-site VPN is working fine from the head office to the branch office. Now jump back to our branch office and same initiates a ping and trace path to our head office client. Open the terminal initiate a ping 10.0.20.10. It's working now. Now initiate a tracer in Windows or trace path in most of the Linux terminals. Our site-to-site VPN is established between the head office and the branch office successfully. Now both offices can share and access each other's information. Both can access their network resources and contrarily. Alright, now the final notes here. And sure enough, you can see that a connection is established. And that's it. That should give a good idea of how to create a pfSense site-to-site shared key VPN tunnel with pfSense 2.7.0, which is the latest release at the time of this recording. In the next part of this series, we will convert this deprecated non-standard peer-to-peer shared key, as it does not meet current security standard, to more advanced SSL and TLS to meet the security standard and stay encrypted. That is all for the now. If you want to see more awesome training content, make sure you click that subscribe button. Click it so you don't miss it. Or if you have any issues or questions, you can reach out to me and I'd be happy to help you out. Thank you.